Okay, our next speaker is Jonathan Jacky. His topic is automatic formal verification for EPICS. Jonathan is a research scientist at the University of Washington Medical Center in Seattle. He has more than 30 years' experience in software development for radiation therapy, including treatment planning, data management, and control systems. He also has experience in automated software testing and formal verification. Jonathan is just getting wired up.
So, at our hospital in Seattle, we have a cyclotron, and we do radiation therapy for cancer with neutron beams. We've actually had this system at Seattle for over 30 years, and we've gone through 3 generations of control systems. Our most recent generation, which we've been treating patients with now for about 2 years, was developed with the EPICS software framework. So this is a safety-critical system, and the safety requirements look like this. The overall safety requirement is that the neutron beam can only turn on or remain on when the setup of the therapy equipment matches a prescription that has been selected and approved by the operator. So, but that overall requirement breaks up into hundreds of more detailed requirements that look like this. The actual gantry angle must match the prescribed angle with the prescribed gantry angle within a given tolerance when the machine is in therapy mode and that setting has not been overridden, and several other side conditions. So these kinds of safety requirements cannot be checked or enforced by simple non-programmable mechanisms like relays or even simple computing systems like PLCs. You pretty much have to use some kind of general purpose computing system programmed in a high-level language. So we had a lot of experience. By the time we began the control system project, we had several years experience using EPICS with the cyclotron side of the installation, and we really liked this EPICS architecture, and we also wanted to have a single tool chain for all our projects. So we wanted to use EPICS for the therapy control system also. However, it seemed to us that EPICS might have a more complicated tool chain and runtime than our previous platforms had. So it is reasonable to ask whether EPICS is a good framework for this kind of system. And actually, a lot of the conventional wisdom says it's not. So, for example, these are some comments that have been made on the Tech Talk mailing list. EPICS is not rigorously audited. Okay, our answer to that is, well, we'll review it and test EPICS ourselves, which we did in an innovative way I'll describe in a minute. Another comment was, EPICS should never be relied on for safety-critical operations. Well, I guess our response to that would be, we don't use all of EPICS. We use a carefully selected subset of EPICS, and then we use that in a restricted programming style, which I'll explain on the next slide. So we're trying to use EPICS with confidence in safety-critical applications. We sort of took 3 approaches. One is, select a restricted subset of EPICS and program in a restricted style. The next thing is we'll develop a new tool for looking for EPICS in looking for errors in our own EPICS program. And then we'll also develop a tool for testing EPICS itself. So, to review the EPICS architecture, you have these embedded computers called IOCs. The programs that run on the IOCs are called databases. All the other stuff, the user interface, the data management, is done on other programs called client programs, which run on other computers. And then the clients and the IOCs communicate using a network protocol called channel access, or CA. So, to simplify this, we just have one IOC for therapy control. The entire therapy control program runs on that IOC. That IOC executes the control laws and enforces all the safety requirements. And to do that does not require channel access or any contact with any client. The clients are only used to provide a user interface and also to provide operations that make progress, like selecting and loading a prescription. But actually executing the control laws and maintaining the safety requirements is done totally on the IOC without channel access and without the clients. So therefore, we are our tools and our analysis, the formal tools and analysis, only look at the IOC program itself, not channel access or the clients. So then in our database program, the program that runs on the IOC, we also restrict what we do, and we use it in a limited way. We only use database records, nothing else, no state machine language, no subroutine records, no custom device support. The database only uses DB links, no CA links, and all the data flow is forward from inputs to outputs using all those attributes, and we also use just a subset of all the available EPICS record types. And so our formal analyses and tools need only consider this. So the first tool we made is called the EPICS symbolic interpreter, which finds errors in our application program. So it's kind of analogous to unit testing. The input to the tool is an EPICS database, and then you have to write a property. You have to write code for each safety property you want to, or any property that you want to check. For example, if the actual gantry differs from the prescribed gantry, you set an interlock. And then the tool checks that, and either the property is satisfied, or if it's not satisfied, it shows you a counterexample. It actually shows you the values of the EPICS PVs in the state where the failure occurs. And it also generates a trace, which is all the processing along the whole data flow path in which the error occurs. So we have actually found serious errors in our program that we missed by unit testing and by reviews. In particular, that gantry angle code was in fact wrong, and this tool found it. So I want to review that the difference here is that in unit testing, you try to guess, you, the tester, try to guess the input values which might trigger the error. But in the symbolic interpreter, the tool itself finds the input values that trigger the error. Therefore, unit testing is somewhat inconclusive because you never know whether some other input value would have triggered the error. But when our verifier says the property is satisfied, it is conclusive because it really has checked all possible values. The way it checks all possible values is because it considers the calculation formulas in the program as symbolic formulas, not just as generators of numbers. So the other thing we tested was EPICS itself. So do the features of EPICS that we use behave as we believe they do? And so the way we addressed that was to write a tool called the trace verifier. And to do that, we created a formal semantics for EPICS. Now you can think of this formal semantics as essentially just a re-implementation of EPICS in another programming language. And in fact, what it is it's the specification language of the Koch theorem prover. So we wrote a program based on this semantics that checks if a sample of IOC behavior is consistent with our formal semantics. In fact, the trace verifier was also written in Koch and has been formally proved to be correct with respect to the semantics. How about that? So just to review what we're trying to do with the trace verifier, we've got three things we want to make the same. We have the EPICS record reference manual. We have our formal semantics, which we wrote, and there's the EPICS code itself. So we relate the EPICS manual to the formal semantics manually by reviewing, and we can revise that, and then the trace verifier automatically checks whether our formal semantics agrees with the EPICS code. So we ran the trace verifier. We ran it a lot. We generated over 20 million randomly generated IOCs and ran them all and generated traces, and then ran the traces through the trace verifier to see if they were all allowed by our formal semantics. And EPICS performed really well in the sense that it never crashed, and we did in fact never find an error where the RRM, the EPICS manual, said something that was false. What we did find is we did have some discrepancies. Most of them were due to our misreadings and misunderstandings of the record reference manual. But we did find some omissions and ambiguities in the record reference manual, which tend to be in these obscure corner cases, but it's notable. Just to give you an idea of of the kinds of things that the trace verifier found. There were some cases in which default values were not clear. There were some mathematical oddities like an EPICS IOC considers infinity to be unequal to infinity. There's some unobvious handling of callbacks in records that use a lot of callbacks like seq records. There's some unobvious sequencing in the assignments from inputs to register variables in calc records. And the guys who ran the analysis says it's possible to contrive IOCs that demonstrate the effects of these ambiguities. And in fact, the random generation did generate those IOCs. So these are notable, but as it happens, none of these omissions or ambiguities was pertinent to our own control program. So we didn't have to change anything as a result of the findings of the trace verifier. So to summarize, we found that we can use EPICS with confidence in our safety critical application. We've demonstrated successful use of our restricted EPICS subset in a safety critical application, namely a radiation therapy control program. We've also demonstrated a tool that finds errors in EPICS databases, that is EPICS application programs, using an exhaustive analysis. We also tested the EPICS runtime against the record reference manual, and we found a few ambiguities and omissions, but no crashes or outright errors. Well, in the proceedings paper, there's much more detail about how the tools work and how we validated them and how we use them in our workflow. But there's no time to talk about those in this talk. So I'm finished.
Thank you, Jonathan. That was very interesting. Some questions? Many.
Hello. Just very quick question. Which version of EPICS did you use? Did you try?
3.15.2. But actually, that's an interesting, one of the things that the trace verifier found is we changed the version of the EPICS calc library in the course of this development. And the computer science people who built the trace verifier and were running the trace verifier found a discrepancy because they were using the new version of the calc library, but our old version, our production version of the therapy control program, and they found a bunch of things that didn't work. Well, of course, they did work in practice because we hadn't upgraded to the new version of the calc library. But, you know, based on what they told us, we were forewarned about this difference in the calc library, which was in fact a breaking change. And so we would look back at the release notes and we overlooked that. I guess we have to change our program. So the answer is we use several versions of EPICS, and actually the tool helped us make the transition from one version to another.
Yeah, thank you.
Just next to that one.
Is the tool available?
Is what?
The tool is available.
Contact me. I mean, it might be. I mean, the authors of the tools are reluctant to release them publicly because they're still very much in flux. So they said that what they told me was, if anyone expresses interest, you know, contact them through me. So if you're interested in evaluating it, I think they'd be very interested.
Thank you.
We have time for one more. This gentleman with a checked shirt.
I would like to know if here.
Oh.
I would like to know if you just decided to go for EPICS blindly and then try to prove if this could do the work, or if you did any kind of preliminary work to understand if there was already an available solution, like on the market, something that had already been certified that could do the job.
Well, no, we didn't seriously evaluate anything else. I mean, the preceding version of, well, we did evaluate a homemade C program running on VxWorks, because that's what the previous therapy control system that we used that we'd used for, 15 or 16 years. And we thought, based on our experience with EPICS, with the other parts of the accelerator, that would be better than plain old C on VxWorks, which our experience has borne out. Whether there is some other platform on the market that's certified that would be better, you know, we did not seriously look, because basically I'd looked around casually and concluded there wasn't. But I mean, I can't say I looked at this one, I looked at that one, I looked at the other one. I sort of looked around a couple of years ago and I wasn't impressed, but I can't remember which ones I did. And the evaluation, to be honest, was not very thorough.
Thank you.
Okay, thank you, Jonathan.